Hello students, today we'll discuss IB Mathematics HL Paper 1, May 2019, times on 2. No calculator can be used in this paper. My name is Nariman Malim. I'm located in Baku, and here you can see my mobile and email. Sources: textbook Oxford 2012, and for sure you should have formula booklet according to the cover page. A clean copy of the Mathematics HL and further Mathematics HL formula booklet is required for this paper. Let's start. Section A. Question 1. In an arithmetic sequence, the sum of third and eighth term is 1. Given that the sum of the first 7 terms is 75, determine the first term and the common difference. So I make reference to the formula booklet. So section 1.1, the nth term of arithmetic sequence looks this way. Because third and eighth term give sum 1, so we write u3, u8 equals 1. Then substitute expression for each. N equals 3 and then n equals 8. And we get this formula. The sum, then again 1, the sum of nth term of arithmetic sequence, 7 terms give us 35, so we put n equals 7 and sum equals 35. We get, after simplification, we get another expression, so we have two equations. If we substitute 2 into 1, we'll get equation for D, so we solve it for D, and then from 2, knowing D, we can find U1. So D is minus 3, U1 equals 14. Done. Question 2. 3 points in three-dimensional space have coordinates A and B and C. Find the vector AB. So vector AB equals vector B minus A. So we subtract coordinates and we get new vector. AC will be vector C, which AC, so vector C minus vector A, we get another vector. Hence or otherwise, find the area of triangle ABC. Area of a triangle from section 4.1 is given as 1/2 of product, vector product. Vector product is given by this formula, and after substitution you will get the following values of vector, and you can calculate magnitude. Magnitude will be square root of one coordinate plus square of another coordinate plus square of third coordinate. Question 3. Consider the function. The graph of f is translated 2 units to the left from the function g. Express g in the terms where a, b, c belong to z. So translation to the left means that we increase value of x by 2. So we put instead of x, x plus 2. Using binomial theorem, where coefficients are given by combinations and n equals 4, and r is changing from 0, 1 till n, we get for different terms. For the first term we get this expression. Coefficients, binomial coefficients are 1, 4, 6, 4, 1. Then we have after simplification we get this expression. Then we have minus 6 x plus 2 by the way, here I forgot to put I don't know why, so all this should be written here also. Minus 6x plus 2 squared is missing here, so let's make a copy from here. We'll make copy to here. And then I think here is addition. Let's check. No, here subtraction. Minus. Right, so we, instead of x we put everywhere x plus 2. And then we watch what happens after opening the bracket. So the first term we did by binomial. The second term, it is square of sum. And the last, one by the last, 2x minus 4, and the last is 4. So after putting all terms according to their powers and adding, we get this gx. So this question is done. Question 4. Using substitution u equals sine x, find this integral. So u equals sine x, it means that du by dx equal cosine x derivative, or du equal cosine x dx. Then section 3.2 of formula booklet, Pythagorean identity, cosine squared equal 1 minus sine squared, or 1 minus u squared. Now we can change all terms into u. Cosine squared 1 minus u squared, cosine x square root of, okay, right, cosine x by dx we change by du, and divided by square root of sine x, which is u, so by a square root of u. Then we use powers of 10, so square root is u to the 1 over 2. So 1 divided by 1 over 2 is 1 u minus 1 over 2 minus u 3 over 2. Then standard integrals in this form, and then we get the value. Done. Next question. Question 5. Sketch graph y equals x minus 4 over 2x minus 4, stating the equation of any asymptotes and the coordinate of any points of intersection with axis. First asymptotes, denominator equals 0. It happens when x equals 2.5, so we draw this asymptote. Right. And second asymptote is we should divide numerator and denominator by x and see what happens when x is tending to plus minus infinity. We see that y tends to 1 over 2, so 1 over 2 is another asymptote. To find x-intercept, we make y equals 0, so y equals 0 means x equals 4. So point is 4, 0. And y-intercept is when x equals 0. In this case, y equals 4 over 5. 4 over 5 is this point. So we have this intercepts and two asymptotes, and we know how the graph looks. So consider the function. This function is square root of our function. It means that we'll have approximately the same behavior, except in this case we don't have this function. Write down the largest possible domain of f. f can take all values except the value on the asymptote. So all possible values, positive values, largest possible domain, so x should be less than 2.5 and x should be more than 4 or equal to 4, because we should not have negative values of the square root of the function. So these values are excluded. This is for domain, and for range it is all positive value except 1 over 2, but when it's squared becomes 1 over square root 2. Question 6. The curve C is given by equation at 0.11 shows that dy by dx equals 2 plus p 2 minus p. So we use product rule, chain rule, and derivative of tan for this function, and we get the following. So first product rule, x tangent, then x and derivative of tangent. Derivative of tangent will be chain rule, tangent, and derivative what we have here. Here we have product, so product we will use this rule. So we first x and then y. So derivative of x is 1, derivative of y is dy by dx, and we have here coefficient pi over 4, which we just keep. At point x equal 1, y equals 1, we get the following values, and finally we see that dy by dx equals 2 plus p, 2 minus p, done. Then question, hence find the equation of normal to C at 0.11. Gradient of tangent we found, it will be dy by dx. Gradient of normal times gradient of tangent is minus 1. So normal at 1, 1. So general formula for normal will be y equals minus 1 over gradient of tangent. So we substitute the values that we got. And at 0.11, from 0.11 we find C. So we put 1, 1 and find C. C equals 4 pi plus 2. So equation of normal is this. So this question is done. Solve the simultaneous equation. So using page 275 of textbooks for properties of logarithm, we do the following. 1 we turn into logarithm 2 over 2. Then this 2 times 2 goes as exponent of y squared. This is second property. Then first property, sum, we turn into product. And then what is as a base, we make them equal. The same we do with the second equation. And we get two formulas. Out of these two formulas we get 6x, so left parts are, right parts are equal, so we make them equal. We have quadratic equation. Solution of quadratic is given by this formula. In our case, a equals 2, b equals minus 15, c equals 25. We substitute, we get two values of y, 5 and 2.5. Now from the one of the equations, for example, this one, easiest, we get the value of x. So for y equals 5, it will be 25 over 3. For y equals 2.5, it will be 25 over 12. So this question done. Question 8. A right circular cone of radius, so we have picture. A shows that the volume of the cone may be represented. So volume of the cone is height is given, radius, and here we have radius of a circle. We know prior learning the formula of the pyramid. And now we see that r squared, this is r squared, should be expressed in terms of r and h. So first of all, we see that we have right angle triangle, and from Pythagoras we know that r squared equals r capital squared equals r squared minus OX. OX equals height minus radius. Height minus radius. So we substitute expression for r squared in terms of h and r, and this question is done. Given that there is one inscribed cone having a maximum value, shows that volume of the cone is so much. For maximum volume, dv over dh will be 0. It means that h equals 4/3 over r, and we can find the volume. Done. Section B. For section B, solutions will be in the lower part. So I'll find solutions. Question 9. Consider so we have two functions f and g defined on the domain from 0 to 2 pi, fx, gx. The following diagram shows why. Okay, find the x-coordinate of the points of intersection of the graph. So, question 9. Solution is the lower panel. So fx equals gx, expression for fx and gx, double identity for left part, cosine 2x. We use 2 cosine squared minus 2. Then we have only cosine, so we substitute cosine with t. We get formula for t. Solution, we use standard solution. After substitution, we get two values. First value we eliminate as it is cosine and it should be less than 1. The second one we keep, it is 1 over 4. So cosine squared is 1 over 4. Cosine is 1 over 2. So cosine 1 over 2 corresponds to two values in our range. One value is pi over 3 and another value is 2 pi minus. So if we look to the unit circle, so we have the same value of cosine. Value of cosine will be here. Right, so this question is done. Find the area of shaded giving the answer in terms of, right, so here I mostly used mark scheme. So area of shaded area will be plus minus definite integral from the points that we found, between points that we found, f minus g. After simple integration and substitution of known values of sine and sine mostly, we get this expression. Done. So I keep a screen for some time if you want to check. At the points A and B on the diagram, the gradients of two graphs are equal. Determine the y-coordinates of A of the graph G. So question C. Gradients equal first derivative. We find first derivative. They are equal. From double identity we get this expression. Sine we change in sine double angle we change into 2 sine cosine. Then we divide by sine, thinking that sine is not 0. We get cosine. And as we know cosine, we can find the value of g because it has cosine in its expression. So we substitute and we get the value. So question done. Question 10. The random x has probability density function given by this expression. State the mode of x. Mode is the highest frequency. So I decided to draw the graph. So sine, then arcsine, then minus arcsine, then pi minus arcsine looks this way. From 0 to 1 we have function which is decreasing. It means that it has maximum at 0. So answer is maximum at x equals 0. Find integral of arcsine of x. So here we will use integration by parts. U equals arcsine, dv over dx equals 1, so v equals x. So we have 1 arcsine dx equals x, it is v times u, minus, and now derivative of arcsine is this value, times x dx. Substituting using substitution t equals 1 minus x squared, we can easily get the answer. So this question is done. Hence, shows that k equals 2 over 2. So total probability equal 1, and we found we can find the total probability because we know right. So we know integrals, and we get equation. So probability equals 1. So we get equation for k, and after solving we get what they ask us to do. So we found indefinite integral, and this will help us to find the integral of this value. Given that y equals, shows that dy over x dx equals, that's awful, so I decided to use just Mach scheme. Using product rule, chain rule, and derivative of arcsine, step by step, we can, if you do it accurately, you will get this answer. Shows that, so this is shown, and next, expectation is x times value of the function, of probability function. So, and then opening bracket, etc., etc., you can get answer. Mach scheme. Consider the function f of g defined, so we have function logarithm absolute value x, gx logarithm x plus k. Describe the transformation by which fx is transformed to gx. Move to left k units. State the range of g, any value. G is any value. Sketch the graph y and x on the same axis, clearly stating the points of intersection with axis. The graphs, so we have graphs. Let's make it bigger. So we have graphs, and we can find intersections. So here x equals 0, and here, and here, and here, and here y equals 0. So here we have fx intersects x-axis as 1 and minus 1, gx intersects fx at 1 and minus 1, gx at 1 minus k minus 1. Here, mistake, right. So explanation is here, so y equals 0, x either 1 or minus 1. Here y equals 0, x plus k equals 1, or x plus k equals minus 1, absolute value. And gx intersects y-axis when x equals 0, and this happens at point 0 logarithm k. Let's see, last question, I guess. The graphs f and g intersect at point P. Find the coordinate of P. So at P, logarithm x equals logarithm minus x. So x equals minus k, and minus k logarithm of k over 2. The tangent to y at passes through origin. Determine the value of k. So this is a function. Derivative will be again 1 over x, and as we know, right, so derivative at point P, x equals minus k over 2, so x equals minus k over 2, so dy by dx at this point equals minus 2 over x. Passes through origin, it means that c equals 0, and y equals mx, or y over x equals m, and m equals dy by dx. So we substitute the values at point P, and from this we find that k equals 2 to the e's power. Paper is over. Thank you for your attention.